Hello, I'm going to discuss about concepts, principles and practices of a nuclear power plant. Nuclear power plants generate electricity through nuclear reactions, typically involving uranium fuel. The process involves splitting uranium atoms to release energy. This heat is used to produce steam, which drives turbines connected to generators, producing electricity. Nuclear power is known for its low carbon emissions but raises concerns about safety, radioactive waste, and the potential for nuclear accidents. Advanced designs aim to address these issues. Emphasizing safety features and waste management, public perception varies, with some advocating for nuclear as a clean energy source, and others expressing concerns about its risks. Nuclear power plants operate based on principles of nuclear fission. Here's a simplified overview. Fuel enrichment. Uranium-235 isotope, a fissile material, is enriched in the fuel rods to enhance its concentration. Fission reaction. Neutrons bombard uranium-235, causing its nucleus to split, releasing energy in the form of heat. This is a chain reaction, as each fission event releases more neutrons that can initiate additional fissions. Heat generation. The heat produced during fission is used to heat water, producing steam. Steam turbines. The steam turns turbines connected to generators, converting the heat energy into mechanical energy. Electricity generation. The rotating turbines generate electricity in the generators through electromagnetic induction. Cooling system. Excess heat must be managed to prevent overheating. Cooling systems, such as water or gases, absorb and dissipate this heat. Control rods. Control rods made of materials that absorb neutrons are used to regulate the rate of the chain reaction. Inserting or withdrawing these rods adjusts the power output. Safety systems. Multiple safety measures, including backup cooling systems and emergency shutdown mechanisms, are in place to prevent accidents. Radioactive waste management. Nuclear power plants produce radioactive waste. Proper storage and disposal methods are crucial to minimize environmental impact. Regulatory oversight. Nuclear power plants operate under strict regulatory frameworks to ensure safety, security, and compliance with environmental standards. Nuclear power plants harness the energy released during nuclear reactions to generate electricity. The primary practice involves using uranium fuel rods to initiate controlled fission reactions, producing heat. This heat is used to convert water into steam, which drives turbines connected to generators, ultimately producing electricity. Stringent safety measures are in place, including redundant cooling systems and rigorous regulatory oversight, to prevent accidents and ensure public and environmental safe. Proper disposal of radioactive waste, adherence to strict operational protocols, and ongoing maintenance are integral to the responsible operation of nuclear power plants. Continuous research aims to enhance efficiency, safety, and explore advanced reactor technologies for sustainable energy product.
Ocean Thermal Energy Conversion, OTC, is a renewable energy technology that harnesses the temperature difference between warm surface seawater and cold deep sea water to generate electricity. Concepts. 1. Temperature gradient. OTEC relies on the natural temperature gradient in the ocean, where surface water is warmer than deep water. 2. Working fluid. A closed-loop system uses a working fluid with a low boiling point, such as ammonia, to transfer heat from warm surface water to cold deep water. 3. Power generation. The heat transfer causes the working fluid to vaporize, driving a turbine connected to a generator to produce electricity. Principles. 1. Heat exchange. OTEC systems use heat exchangers to transfer thermal energy from warm seawater to the working fluid, and then from the working fluid to cold seawater. 2. Rankine cycle. OTEC operates on a Rankine cycle, a thermodynamic cycle that involves phase changes of the working fluid. 3. Efficiency. OTEC efficiency depends on the temperature difference between the warm and cold seawater, Greater temperature differences generally result in higher efficiency. Practices. 1. Open versus closed cycle. OTEC systems can be open or closed cycle, with closed cycle systems using a working fluid that remains enclosed within the system. 2. Platform types. OTEC plants can be located onshore or offshore, and platforms vary in design based on the specific type of OTEC technology being implemented. 3. Environmental impact. OTEC has potential environmental benefits, such as reducing dependence on fossil fuels, but its impact on marine ecosystems and local environments must be considered in practice.